Good morning everyone, my name is Dr. Nikhil Rathi and today I am going to teach you about relativistic mechanics. So the first topic in relativistic mechanics is frame of reference. So what do you mean by frame of reference? As you understand, system of coordinates axis which defines the position of a particle or specific location of an event is called a frame of reference. So understand. Yeah. So, a system of coordinate axis which defines the position of a particle or specifies the location of an event is called a frame of reference. So, what is the actual meaning of frame of reference is, suppose we have a coordinate system. We call it x-axis, we call it y-axis. Now we are watching an object moving from 0 and position of an object is this. So we can give you the coordinates of x1 and y1, and this, if we join the line from 0 to this P point, we call it position vector. Now, suppose in t time, that man moves a distance from P to Q, and now his coordinate are x2 and y. So, what will be the position? Then position of this object from this particular point is x2 and y. So frame of reference comes from, if you want to understand the meaning of frame of reference, then this point is a frame of reference from which we are observing the motion of a man moving from P to Q. So this is called a frame of reference. Now, if you see a figure here, we have x, y and z coordinate system, and we are observing, observer is here at O, and we are watching an object at P, and the coordinate of that system is P, x, x, y, z and t. Now the question arises, how many type of frame of references are there? So if you talk about types of frame of references, then we have two type of frame of references. One is inertial frame and one is non-inertial frame. So we'll take one by one. What is inertial frame and what is non-inertial frame? So inertial frame. So if you talk about inertial frame, if you talk about inertial frame, as name suggests, two frames are said to be inertial with respect to each other if there is no acceleration between them. That is unaccelerated. The first point which comes when we are talking about inertial frame is, it is unaccelerated motion. Unaccelerated motion. What do you mean by unaccelerated motion? Suppose a man is sitting in a bus. Observing another man who is sitting on that particular bus. He will say that this man is at rest with respect to this man. And this is what inertial frame is. We call it a reference frame also. So two frames are said to be inertial with respect to each other if there is no acceleration between them. That is unaccelerated. In such frame, all the laws of, which is very important, that in such a frame, all the laws of Newton's mechanics holds good. That means all the equations which were given by the Newton holds good here. So this is called inertial frame. So the example as I have explained, the person and the vehicle are inertial frame as shown below. So if we talk about another one, the next example is your non-inertial frame. Non-inertial frame. So what is non-inertial? Okay. Two frames are said to be non-inertial with respect to each other if there is an acceleration between them. So accelerated motion. So if it clearly says that if it is an inertial frame, that means non-accelerated system and the object is at the same place. And if you talk about non-inertial frame, then it is a accelerated motion. That means everything is moving with respect to each other. You can see the example of it. In the previous one we said this man observed this man and they said that they are at rest. But if you talk about, if I'll say this man is observed by the driver, the second one, then it is a non-inertial frame. Why? Because its velocity may be v1 and his velocity will be v2. So when, and as name suggests of acceleration, acceleration is a change in velocity by change in time. So if we talk about change in time, change in velocity with change in time, then only a motion can be called as accelerated motion. So now we will talk about Galilean transformation. Okay, before Galilean transformation, I would like to tell you about, okay, so there is a concept of relativity. Relativity. So what is that? Relativity. So when two objects are moving with respect to each other, then we call it a relative motion. That means whenever two objects are moving and we are observing one with respect to other, then we can say that is a moving object or a relative motion. For example, we'll take example of this. Suppose this car is moving with a velocity of v1, or we say va, and this as vb, and a man is observing it. So how will you explain it? So if we want to calculate the velocity of A with respect to B, then we have to say that velocity of A minus velocity of B. What is that? Here the B is an observer, and A is moving. That means in physics we always consider that an observer always thinks that I am at rest. So here if I talk about this situation, VA and VB, they both are moving, but the person on the yellow car observes the motion of the A car and he thinks himself as a constant or at rest. That's why we call it VAB and velocity, and how we will pronounce it? Velocity of A with respect to velocity of B. So here the second one is an observer who always thinks himself as at rest. So this is the basic concept of frame of reference and relativistic mechanics. Now we'll move to more complicated thing. Yeah, this is a Galilean transformation. So the relative, we have studied about Newton's law, but what we have considered in that is everything is at rest, right? So if we talk about are we at rest, then the answer is big no. Why? We are living on Earth, but Earth is not moving. It is moving. That means we are constantly moving, but the concept of frame of reference comes here, or you can say it comes under picture. So if you talk about frame of reference, how we can explain it? if we are moving, if we are staying on a earth and we say that we are not moving, but we always study that earth is moving, then how can we say? Because we are living on that system only where all the thing has happened. So Newton's law basically are observed when or considered when all the objects are not moving. But is it a possible or actual scenario? The question is, the answer is big no. Why? Because we are constantly moving with respect to some other. If you talk about sun, we are revolving around the sun. If somebody watching us from the moon, then he will say no, you are moving. So the first concept was given by the Galilean, and we call it Galilean transformation. What he said is, the Galilean transformation equations are used to transform the coordinate position and time from one inertial frame to the another. The very important part is it explains the concept of position and time from one inertial frame to other. So the concept is remain the same as of inertial frame. So the equation relating the coordinate of a particle in two inertial frame are called as Galilean transformation. What he explained is, I'll explain it. Suppose we have two frames. We have two frames. This is my x, y, and z, and we call it. We can call it S or F, whatever we want to say. It is a constant frame. Now we consider another frame which is coinciding with it, and now in time t we start moving it like this. So my S frame will remain at constant place and my second frame will start moving with it. So one frame is moving with respect to each other, but in what frame? We are moving in a inertial frame. That means we are considering that all the Newton's laws are holds good here, and this is a non-accelerated motion. So suppose we have one frame which is called S frame or F frame, and now the second one is coinciding with it. Now what happens is we'll start moving like this in x-axis. So in t time, what we'll observe, we will have another frame like this. We have another frame like this, and we call it S dash or F dash. So this frame is moving in which direction? It is moving in x direction. That means all the component on y or on z will remain same, but what is changing is my x direction. So this is what we have explained over here. So we'll see from here. Okay, so you can see from here also, this is a S frame, and in time t it moves a distance of vt. How it moves a distance of vt? We have the example. The distance is called velocity into time. So in v velocity, in time t it moves a distance of v, and that means it moves a distance of v into t, that is this. So we are considering that it is coinciding with each other, and in time t the second frame start moving with a velocity of v, and at any time we have seen that there is a distance of vt in. Now what happen is we'll consider that there is a point P and something has happened at that point. Now what happened? One observer from the constant frame and one observer from the moving frame will observe the event, what happens at P. So they have their own perception. They both have their own perception. One will say it is at this distance and one will say it is at that distance, because it is most important part of this is how we are observing the thing. So he is observing the thing at a constant or at rest, but it is observing the thing on motion. So the perception of both will different, but they both are correct. So this is the explanation of it. So one event has happened over here, and we call it, with respect to this frame, with the constant frame, we'll say its coordinates are x, y, z and time t. And in the same time, the observer from O dash, this is O, and O dash will say that no, the coordinates are x dash, y dash, z dash and t. So this is very important part of it. So one event has happened at point P, one is observing it from the constant at rest, and one is observing it while motion. So let the frame f dash is moving with constant velocity v with reference to frame, as I have explained. So now we'll consider how we can make a formula out of it. Okay. So let some event occur at point P at any instant of time being, as I explained. So I'll make it again. So this is the distance between them is Vt. The point is over here. We have two coordinate system as x, y, z and t with respect to O, and x dash, y dash, z dash and t dash with respect to O dash. Now one observer observe it from here, and he say the distance between them is x, while the second one who is moving with a constant velocity v, he will say that this is a distance is x dash. Okay, so he says it is at this distance, and he said this is at this distance. So how will we can formulate it? We will formulate it like this, which is very important and very easy. So this is my complete distance or displacement, we call it x. So how this x is made up of? The question is how this x is made up of. We can say that if we add this distance with this, we'll get the answer. So this much answer is there. We know this distance and we know this distance. If we add both of them, then we can get this value. So which is very easy. So x is comprises of x dash plus vt. Is made up of x dash plus vt, or we can write, this is my first equation as you can see from here. Now the second one, rearranging it, and that will come out to be x dash is equal to x minus vt. Which is second equation. If you see the second one, x dash is equal to x minus vt. This equation himself is saying something, and that is this frame x dash is moving. Why? This x is constant from there, but x minus vt, that means x is something is getting minus from the constant value. So this is called our Galilean transformation. Now as there is no relative motion between, as I explained you earlier also, there is a relative motion between x-axis only, not in y. You can see from here, they are at coincide. Now they are moving. In which direction they are moving? They are moving in a x direction. Now see this direction, they are parallel to each other. If you talk about this, it is parallel to each other. And what we have learned from the vectors, and it says that you can take the vector with the same sign, with the same magnitude in any plane. It will give you the same value, and this is the same thing. So your y-axis is coincide with the y, which is parallel to each other, and your x-axis or y-axis also parallel to each other, that means there will be no difference in that, and we can say my y dash is equal to y, my z dash is equal to z, and as I explained you earlier, we are considering the value of t as constant, so we can say my t dash is equal to t. Okay. Now these equations are called as Galilean transformation equation, and the inverse Galilean transformation can be written as, this is the same thing. We can write it as, we have explained it earlier here, we can write it as x is equal to x dash plus vt. So hence transformation in position is variant only along the direction of motion of the frame, and remaining dimension y and z are unchanged under Galilean transformation. At that era, scientists were assumed time should be absolute. Time should be absolute. That means while they are moving from one frame to another, the time elapsed between them is constant, which we call it t. Okay. So some more formulas are there. Okay. Transformation of a velocity. Transformation in velocity component, which is very easy. We know how we can explain. We have displacement x and we want to transform it into velocity, which is very easy. Differentiate it. So velocity is nothing but dx by dt, right? If you want to transform a displacement into a velocity, what will you do? You will do a differentiation. So if we'll do a differentiation, then my v is equal to dx by dt. We'll do the same thing over here. How? I'll explain you. Okay. What we have? We have x. Sorry. What we have is x dash is equal to x minus vt. Don't we have this? We have this. Now, if we differentiate on both sides with time t, then what we will get is differentiation velocity. So we can differentiate here dx dash by dt is equal to dx minus dt, and when I'll do this, so my v will be a constant and I'll do dt by dt, and which come out to be dx dash upon dt is equal to dx by dt minus v, and we can refine it. We can write dx dash as ux dash because it is in direction of x, and we can say that my ux minus v. So this is my final answer. So transformation in velocity component is very easy. So we can write it as, and you can see from here, the moving frame has a velocity less than what we have in a actual frame. So, and if you talk about the other axis, y and z, what we have explained it, y and z are invariant. That means the velocity on that also will remain invariant. So in next class we'll start with another component, and which is called transformation in acceleration component. Thank you.